Hi, my name is Hasnor,
My name is Harbaj.
and for the bonus physics project, we decided to make a Lego generator to produce enough EMF to light up, hopefully, these LED lights. Our contraption is made up of our conductor, which is copper wire wrapped around this Lego piece many times with some neodymium magnets that we just got off of Amazon. It's powered by motion, so if we just move this piece right here, these gears twist the magnets around the conductor, which is connected to this breadboard, which passes the electrons in a series. This contraption runs on the basis of electromagnetic induction, where you have a conductor with some motion, so this in our case is just us moving it by hand, and connected to a like a magnetic force, which is our magnets. This creates a electromotive force, so an EMF. This essentially means that when you move the conductor through a magnetic field, it causes electrons to move, which is how the electric field is created.
So basically, the electrons within the atom of the copper wire move around freely when not connected to or around a force. When a magnetic is brought near, the electrons start to move in a more orderly fashion, and they start to move in the direction of the wire. Go.
And basically this movement of electrons through the wire generates a potential difference, which is basically otherwise known as a voltage. This voltage then is the cause of a pushing force, which drives electricity, the current in the amount of the stream of electrons that travel through the conductor per unit of time. Okay, so just a principle that you have to keep in mind when making one of these that we did, based on this little drawing that I have, the magnetic field that is being generated has to be perpendicular to the conductor. So in this drawing, if we have our magnets that are spinning this way, we have the conductor perpendicular to that, which just, or like perpendicular to the reverse current flowing through this conductor, which generates that magnetic force.
On the topic of electromagnetic induction principles, strength of EMF usually depends on these certain traits. Firstly, the rate of movement between the wire and the magnet. So basically, how fast these magnets move can dictate the strength of the EMF. Also, the thickness of the wire, the length of the wire, meaning how many loops we have done right here, the number of rotations of wires, the distance of magnet from wire, so basically this distance, we want it to be as small as possible, and also the strength of the magnets themselves.
So basically the principles that were outlined before follow Faraday's law. So we just have this drawn out. There's two laws. The first one is just written whenever the value of the magnetic flux changes with the respect to the coil/circuit, then an EMF is induced in that circuit. So that's just basically explaining how in our generator, we have the magnetic flux changing, which produces an EMF. And then the second law, the EMF induced across the coil is equal to the rate of change in the flux in the coil based on this equation. So just explaining more about this, based on the principle of the amount of coils and the thickness of these coils, we experimented with a thicker copper wire, but we ended up with this thin one. Because even though thicker wire has less resistance and produces it can carry more current, you can't get as many loops in. So thinner wire, you're able to produce more loops, which overall increases the EMF.
Within our experiment, it's okay to either move the conductor or the magnets. In our case, we chose to move the magnets as they're smaller and easier to move. Talking about the magnets, we want the north and south sides of the magnets to face in such a direction that one side of both magnets attract when facing inwards. When flipped around, the magnets start to oppose each other.
And so in our case, we
You
have
didn't
a
even let me
magnet.
finish. When talking about the magnets, in our case, we want the north and south sides of the magnets to face in such a direction that one side of both magnets, that when facing inwards, they attract each other. When spinned around, we want the forces to oppose each other.